Okay, so as usual, after you read the data in, right, you type head of, you can call this anything you want, right? You can use X and whatever, but usually it's a good idea to label the data set with some name that focuses your mind on it. Okay, if you use some generic character like A, B, C, X, Y, Z, and all that, pretty much you will forget about your data after a couple of days. Okay, so we all have a lot of things to do, right? So it's a bad idea if you write your code using generic, storing objects as generic value, generic characters, because you will struggle to recall, all right? Unless they are really for simple things, okay? So we call this wine, all right? And then, of course, then these are your variables, okay? All right, so basically then you can check how many, your dimension of the data, right? The dimension of wine is, we have 178 rows and 14 columns, okay? So 14 variables and 178 samples, all right? The first variable here, the type is the wine type, right? The wine that comes from 3 different parts of regions in Italy. Okay, this data set is from Italy, all right? And these are the variables measured. Now, if you look at the variables measured, right, what do you notice? What do you notice about their nature? Anyone wants to answer this? What do you notice about the nature of the variables? All continuous. Okay, great. First thing is they are all continuous. So there are no, except the first one, right, which is the type is categorical. Other than that, the rest are all continuous variables, okay? What else? Something very obvious.
Is it the scale of the variable is different?
Yeah, that's right. So you look at the scale, right, or magnitude. You see that some are in tens, like for example, alcohol is in tens, malic acid is in ones, and then you have this non-flavonoid phenol is in decimals, below 1. And then you have proline, which is in thousands, and magnesium, which is in hundreds, right? So the range of the data is going between, is very huge, right? From, you have measurements that they are like range restricted to 0 to 1, and then there are measurements that go very high, right? Okay, so this is another feature. This is telling you that you need to do, if you want to compare the variables, some sort of normalization needs to be done, okay? Right, so you need to normalize the data later, right? In order to avoid artifacts, okay? Artifacts whereby whatever effect they will see is purely because of the scale of the variable that's being measured, okay? And what else? So we got 2, right? Continuous, the scale of the measurements, and what else? Are there any missing data in this data set? Any missing data? How do you check whether there's missing data or not? Of course, you can visually see that, right? Inspect the data set, but this is very tedious, right? So basically in R, you can check for missingness by using a function called is.na, right? So you just put the data frame inside, and then basically this will check true or false, okay? So this is not very useful, but you can actually ask it to sum, right? Sum means you add up. True is given a value of 1, false is 0, okay? So you add up all these true false statements, answer is 0, which means there's actually no missing data, right? Because all of them are actually false, okay? So there's no missing data. And what else?
Maybe can check for outliers, extreme value.
Yeah, sure. Extreme values, we can always check that. That will require some further checking, right? Okay, so we leave that later. But actually, for outliers here, it's not that important to check it because at this kind of analysis, because you are looking at a multivariate situation, all right? So and when you look at multivariate situations, a lot of times the kind of exploration that you do is you do things like principal component, right? Principal component is actually not a statistical inference method, so so therefore outliers are not that important here. But of course, outliers you can always you can actually just proceed with a principal component, and if there are some outliers, they will also show up in the plot, right? Then you can actually go and investigate whether the extreme value is due to natural causes or it's just a recording error. Okay. Maybe I draw attention to the domain knowledge. If you were a domain knowledge person, right? You domain expert, right? What would you notice about the nature of the variables? For example, you all of you have studied some chemistry, right? Okay, so if you look at the names of the variables, what can you say? Overlap of variables. Correlation between variables. Okay, of course, the variables will be correlated to some extent, right? But how about the nature of their variables? Like you look at, you have got alcohol, malic acid, ash, so on and so forth, color intensity and all that. From a chemical, from a chemistry point of view, could you could you make a distinction between the characteristic of these variables? In chemistry, there are two basic aspects, right? What are those two aspects? Is non-flavonoid phenol counted in phenol? Maybe, we don't know, but we can actually find out later in the principal component plot, right? Organic and physical. Okay, that's pretty close, right? In fact, actually, the variables can be classified as either they are measuring the chemical property or the physical property, right? Chemical property would be like, for example, alcohol content, malic acid concentration. Malic acid makes it, if you have high malic acid, it makes it sour. Okay, the sour taste comes from the malic acid content. Then these are ash alkalinity. These are some kind of chemical property, magnesium, right, and all that. But you have most of them are chemical variables, but you have a few that are physical, which is color intensity. Okay, color intensity, hue, and this OD 280, OD 315. This color intensity is the how dark is the color of the wine, all right? So this one, they use a colorimeter to measure, right? So this is a physical property. Hue is the ratio of purple to green. Okay, and it's of course the color of purple corresponds to some wavelengths, right? So they take the ratio of purple to green. So if the wine color is very purplish, right, bluish purplish, then it will be more than 1. Okay, if it is very red, then it will be less than 1. Okay, so and then the OD 280 is a kind of pattern of absorbance based on the optical density of some range between 280 to 315. These are basically some kind of physical properties. Okay, and comparing physical properties to chemical properties, which ones are easier to measure? Which one is actually easier and cheaper to measure? Yeah, for sure, right? Physical, right? Because physical, basically, you just use some instrument, you pass through the, like for example, in this case, it's just a liquid, right? You pass it through the detector colorimeter, then it gives you a reading, okay? So that's very easy to get. Whereas if you want to get the chemical variables data, you need to subject it to chemical analysis. I think in this case, probably do some kind of what do you call chromatograms? Okay, so what is it called? Gas chromatography. Sorry. Yeah, gas chromatography. So that will be more expensive, right? That kind of data will take up more money to produce. Okay, so this information will actually be helpful to you as a consultant, right? Later you will see why it is helpful. Although at the beginning, this may not seem much. Okay, so that means if you see in this case, knowing some chemistry, right, helps you because you are able to come up with some recommendations that are useful to the client. Okay, with respect to physical and chemical variables. If you didn't know any chemistry, then you would have some handicap in terms of the domain knowledge aspect. But of course, you might be able to compensate for that by maybe asking lots of questions to a chemist. Okay, by talking to chemists. Okay. All right. Okay. So we are close to the break time, 7:15. All right. So we'll take a break now, and we'll come back around 7:50. All right. Okay. So I'll end the presentation now, and then I'll see you later at 7:50. All right.